notes are going to be really short, and it's going to be a review of what we did last year. But instead of taking 2 or 3 weeks to do this, we're going to cover all this today because this is review. But we're going to use this a lot in geometry, so we're just going to spend a day going over what we talked about. So today you're going to be able to graph lines from different forms. Okay. Now I would suggest also that you put this on your formula sheet. The first form we're going to talk about looks like this. Does anybody remember what it is when we say y equals mx plus b?
That's an inventory. I remember that. I remember the.
Good. What's it called, John?
I think it's slope-intercept form.
Slope-intercept form. Okay.
Dude, I learned that in 8th grade.
So we have slope-intercept form here. Okay. We have to remember where m equals the slope and the b is the y-intercept. And I'll move this up here in just a second. Okay. So remember with this, with slope-intercept form, y equals mx plus b, the y needs to be by itself. The m is our slope and is usually expressed as a fraction, but it doesn't have to be. And the b is the y-intercept. Remember that can cross in a positive or a negative. Okay. All right, let's see an example of this. Let's graph y equals 2x plus 3. Okay, when I graph, and that should have been all the longer you needed, it's very simple to graph when it's in slope-intercept form. The first thing I do is I look to see the y-intercept. In this case, it's positive 3. It's where it crosses this y line right here.
It goes up 3 and over 2.
So I'm going to start at origin, and I'm going to put a dot at positive 3, because that's where it crossed. Then I'm going to look at this slope. Remember, it's in the m position. It's 2. Now, John was saying correctly, we need to make that look like a fraction, so 2 really equals 2 over 1. Now, that's a positive. Remember, it always, we're going up or down based upon whether it's positive or negative, and this one's always to the right.
So you're going up 2 and over 1 then.
Okay, so from our dot before, we're going to go up 2. So I'm just going to put a dot here and a dot here. So I'm going to go up 2, and I'm going to go to the right 1. And that's where I'm going to end up. So now, all I have to do is connect the 2 dots. Now I put a couple little tick marks on the graph itself, so you can see where I've counted that up. Okay? And then all I have to do is...
Wait, hold up. How did you get up to 5 over 1? Did you start from the 3?
Yeah, you start from the 3.
Alright.
Okay, let me see if I can get this. Oops.
Man, that took this 2 years in a row. I should remember it somewhere.
Okay, so I've graphed that line. Now, just as a quick remembrance, does my line have a positive or a negative slope?
Positive. No,
A
negative.
positive slope.
Wait, no, it's not. Yeah, because negative is when it goes from that side to this side. Like
Correct.
That,
Now, when I look at my formula, or my equation, sorry, not my formula, 2x plus 3, I should look at that and know that my slope is positive, so I should have a positive slope. If I graph that and my line has a negative slope, which would be like this, I know I've made an error somewhere. I've not graphed that correctly. Okay. All right. Now, let's go on and graph by intercepts.
That has to be a positive slope.
Okay, now we're going to talk about graphing lines using intercepts. So let's take and look at this one. 6x plus 3y equals 12. That's not in slope-intercept form because my y is not by itself. So here again, I'm going to be able to graph this. And I can do that by forcing the equation to figure out where the x and y intercepts are. You take your headphones off for me, please. Okay? And I'm going to do that by solving this equation twice. Okay? Remember, any point on that graph has an x and a y coordinate. If I just randomly pick a point there, okay, or the coordinates of that would be 0, 4. Notice how the x is a 0 there. Or if I just randomly pick a point here, the
That'd be
coordinates of that would be
5, 0.
5, 0. So this is 0, 4. This is 5, 0. So remember how we did this? If we can figure out where it crosses the x line and where it crosses the y line, by substituting a 0 in this equation up here to start with and solve it twice,
Well,
I can figure out where they cross.
Since it's a 3y, wouldn't it be over 1 then? So you'd go up 3 and over 1.
Not necessarily. So let me erase this. So I'm gonna write this equation first, one time, and it doesn't matter if I start by finding the x-intercept or the y-intercept. So I can put a 0 in for the x or the y, it doesn't matter. So let's just start by putting a 0 in for the x. Now, a lot of people are gonna say, well, do I even have to write this? You don't have to, because anytime 0 is always
0.
0. So I'm really left with 3y equals 12, which I'm going to divide both sides by 3. So where it crosses the y line is 4. Now that number can be positive or it can be negative.
Or not positive.
Okay, so I'm going to put a dot where it crossed the y line at 4. Let's see if I just didn't randomly pick those numbers earlier. Okay, now I'm going to go back again, and instead of putting a 0 in for the x, I'm going to put a 0 in for the y and solve for it. So you guys go back, I'm going to erase this, you guys go back and solve for x this time and see what we get.
2.
Okay, so I've already heard the correct answer. If I put a 0 in for the y this time, these cancel out, well not cancel out, it just turns to 0, and I don't need to write a 0. 3 times 0 is 0. So I'm left with 6x equals 12.
And you
Divide both
that.
sides by 6, my x is
2.
2. So,
She got that answer for me, just so you know.
Yeah, I'm sure.
I'm going to go ahead and, boy, I'm way off here, but I'll fix this.
Goes down 1, 2, 3, 4, 5.
There we go.
Down 5 over 2.
So I've just gone ahead and graphed that line based upon the intercepts. Now, if I were you, I would put this information on your formula sheet. I would put slope-intercept form on your formula sheet. I know most of you know this, and you understand it, but just in case you forget, okay, it's there. All right? Now, here's the one, or here's the situation that a lot of people struggle with, okay? And it is transforming
never remember this. It's the one thing I struggle with.
Okay, so it has to be in the y equals mx plus b format. So the y has to be by itself. So let's start with a 4x minus 2y equals 9. Now, when you're in slope-intercept form, it is a really quick and easy way to graph. The drawbacks is sometimes the numbers aren't really nice. Okay? So, if we were to take this equation, what was given to us, and transform it to making it look like this, we're going to have to get that y all by itself. Okay? So, here again, I'm going to draw a line right down the equal sign so we know we have two sides. That means I've got to get rid of everything that's on the left side. So I need to get rid of this, and I need to get rid of this, leaving the y. So, remember we get rid of the addition and subtraction first. So how can I get rid of that positive 4x? Not just 4,
Minus
but
4x.
4x. Good. Okay? Because really what I'm doing is I'm moving it from one side to the other. So these cancel out. I'm left with negative 2y equals,
It'd be negative 4x plus 9.
correct. Now I'm going to go ahead and start writing it in slope-intercept form, where it'll be the y equals mx plus b. So notice how I wrote the x first over here and then the y-intercept second. But we're not finished yet with this because my y is not finished, or not by itself. So, how do I do that?
Divide by 2.
Divide everything by what? Negative 2. So I'm going to divide, and I'm going to divide all my parts over here by negative 2. So these cancel out. I'm left with y equals a negative divided by a negative gives me a positive, and 4 divided by 2 gives me
Negative, or positive 2.
positive 2x. Okay? And a positive divided by a negative gives me a negative. And I'm going to just leave it as a negative 9 over 2. Sometimes those will reduce.
Be 4.5.
Yeah, sometimes you'll see it in the decimal form. I don't normally see it in a mixed number form, but we can graph that because this is really okay. This is the format that you'll probably see it in. And then we can go ahead and graph that. So let's go ahead and graph that real quickly. Okay, I've got a graph, a coordinate graph up there, so let's go ahead and graph that. Now I've got let's select these and see if I can get these all to come down over here nice and neat.
Oh. Nope.
Okay, looking at this, let's graph these. These are identical. These are identical slope-intercept forms. So let's graph that. Where's my y-intercept? Negative 4.5. So I'm going to put a dot at negative 4.5 where it crosses the y line. So negative 4.5. And then my slope is what? 2 over 1. So is that a positive or a negative? So from this line, I'm going to rise 2, and I'm going to run 1. So I'm at 4.5, so I'm going to rise 1, 2, and I'm going to run 1. So there is my dot, or my coordinate point. So here again, I'll go ahead and draw my line, connecting those two, and then surprisingly, I got that where it's reasonably close the first time. last one coming up.
This is what it gets.
Okay,
This
this
one's
is
really
one that's not particularly difficult, but one that is hard to memorize. This is point slope form.
Well, we're allowed to use our notes and everything.
You bet, you can use your notes. Anything you've got except your book. That's why we give you that formula sheet,
Even on the
okay?
test. Really? That's what's up.
Okay, right there. We're gonna go ahead and write an equation using point slope form of a line through point P, which is -1, 4 with a slope of 3. So if we've been given a point and a slope, we can remember to use point slope form. Remember, this minus sign is always here, this minus sign is always here, okay? And that'll play a good role on this. And M right here is always our slope. So we're gonna plug in the information we know into slope intercept form. This is my x1 number and this is my y1 number. And my slope is 3. So there's my M number right there.
Oh.
Okay? So the first thing I always do is I just go ahead and I write this, and I write point slope form down. So y minus y1 equals m times x minus my x1 number. Okay? So all I have to do is plug those numbers in the correct spot. Well, here's my x1 number, which is -1, so it's going to go where the x1 number is. And here's my y1 number, and that's going to go where the y1 number needs to be. And my slope, which is 3, needs to go in here.
So it'd be y.
So I'm going to write this
It'd be
as
y
y minus
equals
what?
3 x minus. It'd be y minus 4 equals 3, and then times x minus -1.
Okay, now I want you to look at what I'm doing here.
Well, you can't do that.
Yeah, you
You
can.
can't do, you can't minus x.
Remember what I said, that those minus signs are always there? So this is a minus negative. We need to clean that up. So minus
You
negative,
change them to a positive.
right. The opposite of a negative is a positive. Okay, so you're going to have those double signs, and we need to clean those up. So that would be in slope intercept form. If they ask us to transform it, I'm going to take this and I'm going to distribute.
Yeah, you are.
Camber.
To get this into slope intercept form, I need to get the y by itself. So I'm going to distribute that 3 through. So I'm going to have y minus 4 equals 3x plus 3. I distributed the 3 through as 3 times the quantity of x plus 1.
I don't know what to do.
John, help us out.
You gotta add 4 to both
I'm
sides.
going to add 4. So I'm going to add 4 and I'm going to add those on like terms. So I'm left with y equals 3x plus 7. Okay? Make sure all this is on your notes.
Tis. Those up.